What if the thing you were told should be slow, distant, and unreliable is actually faster than what you trust every day? And what if the reason has nothing to do with hype and everything to do with physics that has existed since the universe began? We live in a world where speed defines opportunity, where milliseconds shape conversations, markets, learning, and connection. Yet most people never stop to ask what speed really means or how information truly moves. When you click a link or send a message, it feels instant, almost magical. But behind that feeling is a journey measured in distance, time, and immutable laws of nature. This is where the story of Starlink begins, not as a brand or a product, but as an idea rooted in first principles thinking. The same way Elon Musk often approaches problems by stripping them down to their physical truths and rebuilding them from the ground up. To understand why Starlink feels fast despite being in space, you first have to let go of assumptions and replace them with curiosity, because the answers are not intuitive, yet they are beautifully simple once you see them clearly. Every signal you send is not a vague digital whisper, but a physical phenomenon traveling at a measurable speed, constrained by the speed of light itself. Whether that signal moves through copper, fiber, or empty space, it obeys the same cosmic rule, and this is where most people get surprised. Light does not travel faster in fiber than it does in space. In fact, it slows down slightly as it passes through glass. When data moves through fiber optic cables buried under oceans and continents, it is not taking a straight line from point A to point B. It bends, detours, and follows infrastructure that was built for geography, politics, and cost, not for pure efficiency. Meanwhile, a signal traveling from Earth up to a low Earth orbit satellite and back is often moving through near vacuum, taking a far more direct path. The distance sounds enormous, but distance alone is not the enemy of speed. Inefficiency is. This is the quiet truth that begins to shift how you think about technology, progress, and even your own limitations. Imagine standing on the surface of Earth and looking up, knowing that a satellite is racing overhead at thousands of miles per hour, closer than most people realize, closer than the abstract idea of space suggests. Low Earth orbit is not some distant void. It is a carefully chosen altitude where physics, coverage, and latency intersect. A signal leaves your device, reaches a satellite in milliseconds, hops across space, and returns to another point on Earth with remarkable efficiency. When you compare this to a fiber signal that may travel thousands of miles longer than the straight-line distance due to routing constraints, the comparison becomes less shocking and more logical. What feels counterintuitive at first slowly turns into clarity, and clarity is powerful because it replaces doubt with understanding. But here is where the tension builds, because understanding speed forces you to confront a deeper question about progress itself. If our instincts can be wrong about something as basic as distance and time, what else are we misjudging in our lives simply because it feels familiar? People often dismiss new systems because they challenge mental shortcuts built over decades. Satellite internet used to be slow, so it must always be slow. Space is far, so anything involving space must be delayed. These assumptions feel safe, yet they quietly limit how we imagine the future. Starlink disrupts not just infrastructure, but expectation, and that disruption is uncomfortable before it is inspiring. The middle of every transformation feels uncertain, like standing on a bridge that is still being built beneath your feet. Physics does not care about comfort, opinion, or tradition. It only responds to reality. When you calculate signal travel time using real distances and real speeds, the numbers tell a story that marketing never could. A few hundred kilometers up, a few hundred kilometers down, multiplied across a constellation designed for coverage and redundancy, suddenly becomes competitive with terrestrial systems that seemed untouchable. This is not magic, and it is not luck. It is what happens when you respect first principles and design around them relentlessly. The lesson extends far beyond internet latency, touching the core of how breakthroughs are made in any field, whether science, business, or personal growth. As you follow this logic, a quiet realization begins to form, one that creates suspense, not because it is dramatic, but because it is unsettling. If speed can be redefined by rethinking paths instead of accepting defaults, then limitations may not be where you think they are, The fastest route is not always the most obvious one, and the future rarely arrives by following the longest established road. It arrives when someone dares to look up, measure reality honestly, and choose a path that seems impossible until the math proves otherwise. In that moment, space stops feeling far away, latency stops feeling mysterious, and progress stops feeling accidental, becoming instead a deliberate outcome of understanding the universe as it truly is. That same mindset invites you to question habits, timelines, and fears, recognizing that with patience, calculation, and courage, the gap between where you are and where you want to go may be shorter than imagined than you think. As this understanding deepens, the conversation naturally shifts from how signals move to why this matters so profoundly in a world obsessed with speed, yet rarely patient enough to examine its foundations. Latency is not just a technical metric. It is a reflection of how close human intention can get to instant action, and that closeness changes behavior, confidence, and creativity. When something responds quickly, it feels alive, trustworthy, and empowering. And when it lags, it creates friction that slowly erodes momentum. Starlink's perceived speed is not an accident of branding, but a consequence of reducing friction in places most people never thought to look. By lifting part of the network into space, the system avoids countless terrestrial obstacles, borders, aging infrastructure, and indirect routes that quietly slow everything down. This is the uncomfortable truth about progress. Sometimes the fastest way forward is not to optimize the old path, but to abandon it entirely. Fiber optic internet is an engineering marvel, yet it is also a compromise shaped by history. Cables follow coastlines, highways, political boundaries, and economic incentives, not straight lines. A signal traveling between two cities may cross oceans, bounce between hubs, and pass through multiple layers of routing logic before arriving. Each step adds a tiny delay, and while each delay seems insignificant, together they create a noticeable gap between intention and result. Starlink reframes the journey by asking a deceptively simple question. What if the signal could take a cleaner path? When data travels up to a satellite and back down, it is not wandering through decades of legacy systems. It is moving through space with minimal resistance, guided by geometry rather than bureaucracy. The result is a kind of digital shortcut that challenges long-held assumptions about what fast is supposed to look like. This realization introduces a subtle tension, because shortcuts are often dismissed as unrealistic or risky until they work. There was a time when reusable rockets were laughed at, when electric cars were dismissed as toys, and when private spaceflight sounded like science fiction. Yet the same philosophy connects these ideas, a philosophy often associated with Elon Musk, centered on respecting physics over convention and prioritizing long-term efficiency over short-term comfort. That mindset does not guarantee success, but it does guarantee clarity, and clarity is a powerful antidote to fear. When you understand why something works, you stop arguing with it emotionally and start engaging with it intellectually. The suspense builds when you consider what happens as more satellites fill the sky, creating overlapping coverage and reducing reliance on any single path. Each additional satellite is not just hardware, it is an increase in optionality, a reduction in delay, and a buffer against failure. Suddenly, the system is not merely fast but resilient, and resilience changes everything. It means connection in remote regions, stability during disasters, and access where there was once isolation. Yet this promise comes with a question that lingers uncomfortably in the background. If we can solve problems of distance and delay so effectively, why do so many human systems remain slow, fragmented, and inefficient? The answer is not technological. It is psychological. People accept latency in their lives the same way they accept it in old networks. They assume delays are natural, that waiting is unavoidable, that dreams must travel the longest possible route before becoming real. But just as with data, these assumptions are rarely examined. The moment you start calculating distances honestly, measuring time realistically, and questioning inherited paths, you discover that many delays exist simply because no one challenged them. This is where the story of Starlink becomes symbolic rather than technical, representing a broader invitation to rethink constraints that feel permanent but are not. In the middle of this reflection lies a quiet moment of doubt, the kind that makes progress fragile. What if the system fails? What if the complexity becomes unmanageable? What if space introduces risks that outweigh the benefits? These are reasonable questions, and they mirror the doubts people face when attempting any meaningful change. The fear of failure often masquerades as practicality, convincing us that the old way is safer simply because it is familiar. Yet physics does not reward familiarity, it rewards alignment. When a system aligns with natural laws, it tends to scale more gracefully than one built on patchwork solutions. As you sit with this idea, the suspense shifts inward. The real question is no longer about satellites or fiber, but about perception. How many times have you assumed something would be slow, difficult, or impossible, simply because it existed outside your usual frame of reference? Space feels far, so space-based internet must be slow. Ambitious goals feel distant, so pursuing them must take forever. Yet distance measured emotionally is often very different from distance measured objectively. Once you calculate the numbers, once you see the path clearly, the gap shrinks. This is the moment where understanding becomes empowering rather than merely interesting. Starlink feels fast because it respects reality instead of fighting it. And that principle applies everywhere. When you stop forcing your efforts through congested routes and instead seek cleaner paths, progress accelerates almost effortlessly. The system does not rush. It simply removes what slows it down. In doing so, it reveals a deeper truth that lingers long after the technical explanation ends. Speed is not about urgency, but about alignment. And alignment begins with the courage to question what everyone else accepts as normal. By the time this realization settles in, the idea of speed begins to feel less like a technical feature and more like a philosophy of living in sync with reality. Starlink's ability to feel fast, despite existing in space, is not a contradiction. It is a reminder that progress often emerges when we stop mistaking complexity for depth and familiarity for truth. The universe operates on clear rules, and when systems are designed to cooperate with those rules rather than resist them, the results can feel almost effortless. This is why understanding latency through real physics is so powerful, because it strips away illusion and replaces it with clarity. Signals do not care about our intuitions. They care about distance, medium, and time. Once those elements are respected, the outcome becomes predictable, reliable, and scalable, qualities that quietly define every lasting breakthrough. What makes this story resonate beyond technology is that it mirrors the human experience more closely than most people realize. Many individuals spend years routing their energy through inefficient paths, chasing validation, waiting for permission, or following routes laid out by tradition rather than intention. Each detour adds its own kind of latency, slowing momentum and dulling purpose. Just as fiber networks were built around constraints of the past, many personal systems are built around outdated fears and assumptions. The lesson embedded in Starlink's design is not to abandon structure, but to re-evaluate it, to ask whether the path you are on is truly the shortest and cleanest route to where you want to go. There is a reason the ideas associated with Elon Musk often spark intense reactions, both admiration and skepticism, because they force people to confront uncomfortable questions about limits. When someone insists on calculating from first principles, it exposes how often society accepts inefficiency simply because it is widespread. This can feel threatening, because it suggests that delays we once believed were inevitable may actually be optional. In the context of Starlink, this means rethinking how information flows across the planet. In a broader sense, it means reconsidering how ambition, effort, and time interact in your own life. The suspense here is subtle but profound, because it asks you to imagine what could change if you removed unnecessary distance from your goals. As the constellation grows and the system matures, the feeling of speed becomes more consistent, less remarkable, and more expected, and that transition is telling. Revolutionary ideas always start as surprises, then become standards, and finally fade into the background as assumptions themselves. The danger is not that innovation stops, but that curiosity does. When something works well, people stop questioning why, and in that pause, new inefficiencies quietly form. This is why understanding matters more than admiration. Knowing why Starlink feels fast equips you to recognize similar patterns elsewhere, to see when a problem is not about effort, but about route selection. The final tension in this journey is not about technology, but about responsibility. With greater speed comes greater expectation, and with fewer delays comes less room for excuses. When connection becomes nearly instantaneous, isolation feels more intentional. When access expands, ignorance feels less forgivable. This is the quiet weight of progress. The way it removes friction, not just from systems, but from narratives we tell ourselves about what is possible. Physics does not judge, but it does reveal. And what it reveals can be both liberating and demanding. In this light, Starlink is not simply an internet service. It is a demonstration of what happens when human intention aligns closely with universal law. The signals move quickly because they are allowed to move honestly, without being forced through unnecessary obstacles. That honesty is rare, and it is powerful. It suggests that the future will not be built by adding more layers of complexity, but by removing what no longer serves the goal. Speed, then, becomes a side effect of clarity, not a product of pressure. As you step back from the numbers, the satellites and the calculations, what remains is a question that lingers long after the explanation ends. Where in your own thinking are you accepting latency as normal, simply because it has always been there? Where are you routing your energy through systems that were never designed for efficiency? And what would happen if you dared to redraw the map? The universe will not change its rules to accommodate comfort, but it will reward alignment with remarkable consistency. Once you see this, it becomes difficult to unsee, and that awareness quietly reshapes how you approach challenges, decisions, and time itself. Understanding why Starlink feels fast, despite being in space, ultimately reveals something far more intimate than a technical insight. It shows that distance is not destiny, that delay is not always unavoidable, and that progress often waits on the other side of a single honest calculation. When you respect reality, reality responds, and in that exchange, speed becomes not a race, but a natural outcome of moving in the right direction. If you are benefiting from our topics, please subscribe, like, and turn on the bell notification so you can see our new videos early.